Hello, Precalculus student. This video is for chapter 4.2, part 3. We will continue with the end behavior of exponential function. This would be a very short video, just talk about the end behavior of exponential function. But this is quite important because this concept is pretty often used in calculus when you do limits. So talk about end behavior means we want to know when x is given a function with some transformation, if x become very large or very small, what happens to the y value? And in limits in calculus, you often need to do a limits to infinity or negative infinity. So it's nice to know. So in the last video, we started this, but we weren't able to finish it. So I'm going to start all over. So I have a graph. Oh, I have a function f of x is 3 base 5 to the x minus 1. We can tell that it is doing a vertical stretch of 3 by a factor of 3 and also down 1. So because there is an up and down transformation, the horizontal asymptote become y equal to negative 1, shift down. And then we don't need to actually, graph it really nice, but we know that this is, well, we can graph it, but we can just sketch it a little bit like this. I don't think it passed through 0, 0. It's not a very accurate graph. Because when x is 0, so this is 3, so this should be 2. Okay, maybe I should undo it and then just erase this and do it again. So like that, right? So when x is 0, we would know that it is 1. 3 times 1 is 3. 3 minus 1 is 2. So the the horizontal asymptote is y equal to negative 1, but you have something like this. So, and it is a, just says a graph, a growth, exponential growth graph. So it's roughly like this. By looking at the graph, you can tell on the left-hand side when x approach, let's describe the end behavior. From the graph, you can tell when x approaches negative infinity, y actually would get closer to the horizontal asymptote, which is negative 1. When x approaches infinity on the right-hand side, you can say that y shoot up, so it becomes infinity. Okay, so that is how you describe the end behavior. If 3, instead of 3, we have a negative 3, you would have a reflection. Then the only things that would change is the y. Instead of going to infinity, you could have a y going to negative infinity. So look at the A carefully. In real life, this would not, right? In real life, most of the time we have a positive A. So both of these examples are positive. The second one is 1/2 x plus 2 and multiplied by 2 outside. So of course the transformation is still a vertical stretch because it's ABX, but I have add 2, right? A vertical stretch, but I would have a up 2. Up and down would affect the horizontal asymptote. We know that the horizontal asymptote now become y equal to 2. It used to be 0 because you add 2. So I'm going to just build a graph like this. We know that this is a decay function because b is 1/2. So up 2 means the horizontal asymptote is here, y equal to 2. And then this is a decay function. That means I'm going down like this. So if x is 0, let's just look at this point. When x is 0, what do I have? I have 1/2 to the 0 is 1. So 2 plus 2 is 4. So I have a 4 here. Like that, like the decay functions. There are only 2 types, right? Either shoot up or drop down. So by looking at this, you can say when x approaches negative infinity on the negative side, what happened? Actually, y shoot up, right? Go to infinity. But when x approaches positive infinity, and this side, y gotta actually become less and less, become 0. It's a decay function. And again, if this is a -2 instead of a 2, you would have to flip over and it would become negative infinity also. But that's not very common in real life application. So that's all for end behavior of exponential function. By graphing, you can use it to describe end behavior. You can also use it to describe the domain and range of the function.